Hello everyone, my name is Nandkishore Yadav from Department of Information Technology, ABES Engineering College, Ghaziabad. In the lecture series of Doubly linked list, so far we have discussed a creation of doubly linked list, traversing in doubly linked list, and insertion at beginning of a given doubly linked list. In this lecture, we are going to discuss insertion at end of a doubly linked list. So we have to write here an algorithm for insertion at end of a given doubly linked. So in this diagram, we can see that we have to given a linked list of 3 nodes. So let's a variable start is also given to us. It will show the address of the starting node of a given doubly linked list. So here we have, let's write an algorithm for deletion for insertion in at the end of this given linked list. So insertion at end. Okay, and here we have to write a start variable which is given to us, start comma data which is assigned when the new node is created. Now begin algorithm here. The first step, what we have to do. So here in this linked list, you can see that we have to write, we have to insert a new node at end. Firstly, we have to create a node. Then let's take a new pointer variable. It's a new variable which will hold the address of created node. So we have to write here create new node, create node, and data is assigned to this node also. Okay. In the next step, we will check if the memory is allocated or not. Memory is allocated or not to new node. We have to write if new is equal to null, means no memory is allocated to new node. Then we have to write here a print overflow means memory is not allocated to new node, and from here we can perform exit operation. We can exit from here. Okay. In the third step, we can see that here in this given linked list, a start pointer is here, and we have to insert this new node at this point. So this is suppose address is again 1500, and this is a new node. Okay. So here you can see that this is last node, but no variable assigned to this node. So firstly, we have to assign a variable to this node. So for that purpose, what we have to do, just we have taken a variable ptr is equal to start. In the third step, we have to move to last node. For that, we have to write a loop here. So repeat while write of ptr not equal to null. Okay. Now this is step number 4. In step 5, we can move this ptr variable. So we have to write ptr is equal to write of ptr. So we have to repeat step number 5 in this loop, and step number 6, Now using these steps, PTR is assigned to this node. Okay. Now if the PTR assigned to this node, then we can easily insert a new node at this point. Now what changes we have to do? This is PTR variable, this is new variable. So here we have to link this node, new node, to PTR, and next node of PTR is a new node. So here we have to change this. We have to write address 500, 1500, and here we have to write the address 3000. At this point of time, we can write null value. So, and data is already we have inserted at that node. So we have to do three changes. First one is write 1500 here, and here we have to write 3000, and here we have to write null value. Okay. Now for that, you can write here a write of PTR is equal to new. Okay, is equal to new, and left of new is equal to PTR. So both node are connected. It means that previous node for this node is this PTR, and next node for PTR is new node now. At last, we have to insert null value at a write of new. At last, we can write here write of new, write of new is equal to null. Okay, and stop algorithm. So here you can see we have inserted a new node at end of the event doubly linking. So this is the algorithm for insertion of a new node at end of a given doubly link. So thank you all for listening me.